Hello everyone, welcome to Chapter 7, Part 2. In Chapter 7, Part 2, we're going to pick up right where we left off with Chapter 7, Part 1. I'm on page 160 in the book, 7.4, creating a correlation matrix. And I'm going to assume, as always, that you've already read through all of this, and I'm going to just walk you through the solutions and do a little explaining as I go. We'll also have two separate methods of accomplishing the same thing, one for the PC user and one for the Mac user. The PC users are welcome to use the Mac method if they prefer. Some may prefer. It is fairly straightforward. And unfortunately, the Mac users won't have the functionality to use the PC method. But both are fairly simple and straightforward in this particular case. I'm in the same worksheet I was at the end of video 1. You could see here, that's the one we did for video 1. So I would recommend you be in the same place. I'm going to be in row 55. For you PC users, you may be up here a little bit since you wouldn't have this equation and this number that the Mac users would. But the first thing, what we're trying to accomplish here, the first thing we're trying to accomplish is to figure out, well, remember from video 1, we used x1 and x2 to predict y. Now we're going to figure out which is the better predictor. Which is the stronger predictor? What portion of the prediction did each of these have? Was x1 a great predictor of y and x2 was terrible? Were they both equal? What's more important? And you can see the value of that, because instead of 2 predictors, what if you had 10 predictors? And do you really need to collect the data from all 10? Or maybe can you pick just a couple and not have to collect all the data? Or maybe you only need one as a predictor and not all the others. So knowing which is the stronger predictor is important. And to do that, we're going to do correlation. So to get our correlation matrix for you PC users, we're going to go to Data, Data Analysis, Correlation, okay, Input Range. I'm just going to input all the data. I'm going to use labels because I like the clarity that it gives us. Grouped by columns, that's correct. Labels in first row. Output range, I'm going to put the output down here at A55. Hit OK. The numbers we're concerned about is the relationship of sales, which once again is our y variable up there, sales, the correlation between sales and number of cars and number of locations. So it's these two boxes that I'm worried about. Before explaining, I'm going to go ahead and calculate those same numbers using a method that you Mac users can use. So I'm going to go down here in row 60, I'm going to say equals, C-O-R-R-E-L, Correl for correlation, array 1, comma array 2. So I'm going to go array 1, comma array 2. Enter. 0.92. Now what I should do here is label what I just correlated, because they won't give you that like the chart above does. So I'm going to go sales slash number of cars. That's what I just correlated. And I'm also going to do the correlation for the other group. So I'm going to go equals Correl open array 1. Don't do labels in this because it won't pick them up. You'll just get a error. Comma. Make sure you pick x2 this time. Close. Enter. So that's our correlation there, and that's going to be sales slash number of locations. So now we have the same data numbers here. See, those match perfectly. I'm going to reduce the decimal points on both sets. Okay. And now I'm going to explain what we've just done. What we found is that there's a 92% correlation between sales and the number of cars, and a 56 a correlation of 0.56 between number of locations and sales. Same thing down here. What that tells me is that the number of cars is a much stronger predictor of sales than number of locations, 0.92 versus 0.56. So you really would only need 0.92 is so strong that in the future all you really would need would be the number of cars to accurately predict sales. It just wouldn't be that important to know the number of locations. And just to kind of show you, the book doesn't do this, so I'm going to go back up here to this equation. And you can almost see this from the equation because 0.17 is such a small number compared to 9.09. So you can even get a feel for the level of importance once again in the prediction. So that explains correlation and how correlation can be used as a predictor, and now you are all set to do the end of chapter problems. We'll see you for chapter 8.